Hello, everyone. It's great to be here. You wouldn't believe the kind of trip I had. I've been traveling for like a day and a half to get here, but I'm finally here. Hola, soy Lea. Hope I said that right. That's pretty much the extent of my Spanish. I've already had a great introduction, but I feel I should really introduce myself as well. That's my Twitter over there. That's my Mastodon. That's cut off. So you can always hit me up with questions if you don't get to ask your questions after the talk. I've been in the CSS working group for a decade now. I've been editing a bunch of specifications, and in the last 2 years I've been in the tag, which is kind of like the review board for all new web platform features. My day job is doing research at MIT. I do human-computer interaction research, which is human-computer interaction is just a word that academics use for usability, just because they like having different words for everything. And I've started a lot of open source projects. You may have used some of them. What is today's talk about? I got the idea for today's talk when I was working on the CSS chapter of the Web Almanac about 2 years ago, and we studied how people use CSS custom properties then. And pretty much, so one of the metrics that we looked at was custom property depth, which is basically how many custom property references do you need to follow to get an actual fixed value. And surprisingly, we saw that 2/3 of custom properties were basically constants. They were just set to fixed values. And also, that was supposed to be, yeah. And also, 2/3 of custom property usage, more than 2/3 actually, was basically globals. Despite the really amazing dynamic scoping that custom properties have, they were still extremely underutilized. So basically, it got me wondering, why is it that we got these amazing reactive, dynamically scoped kick-ass variables, and we're still treating them as glorified constants? Why are they so underutilized? At this point, we've had them for years. They've been supported in every browser for years. So browser support is not really the issue. The issue is how we talk about custom properties, how our code that we post about uses custom properties, and it's all about here, you can reuse colors, you can reuse fonts, but they can do so much more than that. So I decided to create a talk to spread the word about how amazing custom properties are and how much more they can do than what they're used for today. So today's talk is structured as a story in 3 acts. It has 3 parts about 3 components that many of you might recognize, and even if you don't, they're simple enough that we can describe them just in the span of a third of a talk. And each of them is going to introduce certain things that I want to talk about. And in the end, we're going to bring it all together and talk about what did all of this teach us? What is the bigger picture? And without further ado, let's talk about the first component. And I will use components here as a very, very broadly. Most of you know components from like JavaScript frameworks. There are Vue components, there are React components, there are web components that are native to the web platform. Here I'm just going to use components as the very broad term of like a reusable blob of HTML and CSS and sometimes JavaScript. And these don't necessarily need, they can literally just be CSS and HTML that you reuse, which is what I'm going to use here so that we all have a shared understanding. And the simplest ever component is a button, right? And we've probably all done something like this. This is an outlined button. When you hover, it has an accent color, which can be different for different uses. Here I'm just showing a black one and a pink one. And when you hover over it, you get a background that is the same color. Pretty basic stuff. And right now, it's not really using any variables, so there's a lot of repetition. So you've probably all done something like this at some point recently. We're going to use a CSS variable to abstract away this duplication. We're just going to use a color variable for the accent color. And then this allows me to demonstrate how more succinct a variation can now be. Instead of having 2 rules and several lines of CSS, it can now just be a single line. In fact, we can now create ad hoc variations by just specifying this variable through the inline style. And since we can specify it through the inline style, we can even write JavaScript that creates variations on the fly, because why not? So here I'm just going to write some JavaScript that sets the accent color to a color of a random hue, so that every time I click this button, I get a completely random accent color, because why not? And yes, I've used an inline event handler here. It's a demo, deal with it. So our first takeaway, which you probably already know, but just to get everybody on the same page, CSS variables are just regular properties. In fact, they're actually inherited properties by default. Now, the code we wrote required us to override a button to set an accent color. So everybody that wanted to consume our code and use our component would have needed to know, A, what specificity we've used in our rules. And also, it means that they couldn't set a global -- color because that would break inheritance. So how can we fix that? We can use the fallback parameter in the var function to specify a fallback. But and this would work. This does allow us to specify a fallback so that not everybody that uses our component needs to specify -- color. But it does have a bit of a problem. So can you see what the problem is here? Repetition. We had to specify this fallback 3 times. That's not great. So you might think, OK, well, since we're using CSS variables here, I know how we can reduce repetition. We're going to use a variable for the fallback and call it color initial for the initial value. And that would work. See, it works. That works just fine. But is that good? That means we have to use this super long thing every time we want to reference -- color. That's not great. It's extremely long. I mean, yes, it works, but it's kind of awful. So can we do better? We can use what I call pseudo-private variables. I mean, it's just a naming convention. We use the same name as the actual variable that our component exposes to third parties. And we just reference the same variable, but we bake the fallback in. So, and in the rest of our code, instead of using -- color, we use _color. This might look kind of hideous, but do note that JavaScript has gotten away with that sort of thing for something like 20 years. So if JavaScript got away with it, CSS can as well. And again, people often get confused about this. Pseudo-private variables are not an actual syntax thing. They're just a convention. Like by convention, we decide to prepend names with _ and have this mean this variable includes a fallback. It always has a value, whether it's set by third parties or not. So to recap, pseudo-private variables help us reduce fallback duplication. I mean, we can still alias black to another variable and call it color initial if we want people who use our component to be able to set the initial color as well separately. But that's a separate thing, and usually we don't need to provide that kind of API. Now, right now, the hover effect is abrupt, so we want to add a transition to make it more smooth. So we just write transition 1 second, it animates what it can animate, but we don't actually like this effect. We want something different. We want the stroke, the border of the button to sort of grow inwards and animate that way and like fill in the button gradually. So what can we do? CSS doesn't quite let us do that sort of thing, so we're going to use a box shadow instead of a background. So we're going to replace the hover background with a box shadow that just has no blur and just a big spread in its inset, and it just grows inwards. And that gives us the effect we wanted. And why am I showing you this in a talk that's about CSS variables? It's not a talk about transitions. Because this demonstrates a very important point, that CSS variables allow us to create this sort of encapsulation where someone else might have used our button, overridden, different variations through --color. And when we released a version like 1.2 that included this different hover effect, they did not have to change their code. We did not need to communicate that anything about that component had changed. They just get the change. Whereas previously, before custom properties, we would need everybody that wanted to use like version 1.2 of our component to know that the hover effect has now changed. If you have used a different color, if you have overridden the accent color, you need to update your hover effect. And I think that is a very important point, that CSS variables allow us to create this higher level styling API where people just set these little design tokens and our internal style just adapts to them. So essentially, CSS variables allow us to create this kind of API, which actual component libraries have already started using. Shoelace, which is my favorite web component library, already includes a section for CSS custom properties that lists all the custom properties that each component supports. And obviously, these are a lot more higher level than regular CSS properties. Now, another thing I want to show, and let's go back to the previous background version of the code so that it's simpler. Let's suppose that instead of having one accent color, we wanted to have many. We wanted to have an entire rainbow, or at least to have a variation that does this. So we create a rainbow class, and we set the color to be an HSL color where the hue is set to a different variable that we call color hue. And then, quite naturally, we create an animation that animates this variable from 0 to 360, but we're going to do 0 to 180 right now, just for debugging purposes. And then we attach this animation to our rainbow button. And let's see, did it work? Not quite. It just goes between these two colors with no animation. Why is that? This is because the browser doesn't actually know how to animate color hue. It doesn't really know that it's a number and that it should animate it as a number. I mean, sure, it looks like a number, but we haven't declared that it should be animated as a number anywhere. I mean, remember that CSS itself used to have a font weight property that also looked like a number, and it was actually keywords until recently. So can we somehow tell the browser, hey, please animate this as a number? Turns out that we can, with the add property rule that allows us to declare metadata about custom properties. So we can say that this is a number. We can even specify an initial value for this number. And we can customize whether it inherits or not. And now our animation works now. And we can hover at any point during the animation and get the hover effect for that color. And to finish off the effect, let's make it 360, so that it goes through the entire rainbow. So the takeaway from this is that CSS variables cannot be interpolated unless we register them with that property. This has been the source of a lot of developer pain. Pretty much everyone, once they get comfortable with custom properties, they try to animate them, and then they're like, why doesn't this work? There's also a JavaScript API for this. Usually, add property is a better bet, but there are certain use cases where the JavaScript API can be better. And since we now have a way to declare metadata about a variable, including an initial value, we can actually declare our color variable as well and give it an initial value of black. And then we do not need the pseudo-private variable anymore. We can just use --color, and if it's not set, its initial value is black. However, this is not perfect for a number of reasons, and we might want to use pseudo-private variables anyway, even once add property is more widely supported. The first reason is that add property is global. So once you declare metadata for --color, that applies for everything in your page. Unless you're actually using a proper web component with a shadow tree, in which case it's scoped to that shadow tree. But otherwise, if you're just writing regular CSS for the light DOM, then it's global. And usually, you don't want it to be global. Like here, we've defined this button that uses its own dash dash color, but we probably don't want to set a default value for any dash dash color on the page. Right? For other use cases, it might make sense for the default value to be transparent, not black. And another reason is browser support. CSS variables are pretty much supported in any browser you need to support today, except for the very few of you that need to support I11. Whereas with @property, the story is much more dire. Although I do know for a fact that Safari is currently implementing it. There have been commits in the last few days for @property, so the support story is going to look a lot better in like even a couple of months from now. And even the fact that it's supported in Chromium-based browsers does mean that its market share is like 70%, just because of the huge market share of Chromium. So don't be too discouraged by this picture. Now, for the second component, called the glossy button, is going to teach us a little bit about conditionals. So I've talked about how CSS variables basically allow us to create a sort of API, and that component libraries like Shoelace already expose this kind of API, and that's great. And in the tag, we have this set of guidelines for web component authors, and most of these are followed by popular libraries, and they're pretty common sense. However, there is one guideline that even though it makes perfect sense, it's not actually that followed. It says, don't use custom attributes for styling, like BG color, for example. Instead, use custom properties or CSS shadow parts. Makes perfect sense, right? Why would you want to use presentational attributes in your HTML? And yet, all the popular libraries do this. There is a size attribute. There is an outline attribute. There's even a pill attribute to make the button look like a pill. Like, if that's not presentational, I don't know what is. So why does a library like Shoelace, which is like super well supported, like very well maintained, like really clever people behind it, why does it do that sort of thing? And the reason is because right now you cannot do these things with CSS variables. You cannot have conditionals that say if dash dash pill has a value of on, for example, apply this border radius. Otherwise, apply this other border radius. At least not with keywords like this, not as nicely as this. In the hopefully near future, we will be able to do that sort of thing. How many of you have heard of container queries? Not that many. OK, well, you're in for a treat once you read more about container queries, because they're amazing. And they're being implemented right now. So container queries allow us to, you know how with a media query you can have a query about your entire viewport and vary styling according to that? With container queries, you can scope that down to a particular component and say, like, if the width of this particular component is like bigger than 500 pixels, then apply this styling inside it. And with style container queries, we can query specific values of custom properties. So we will be able to say, if dash dash glossy has this value on, then apply these rules inside. Whereas if it has the value off, apply these other rules, conditionals, which will allow us to have much more higher level custom properties where a single value controls a number of declarations and even bring in nested rules and whatnot. And with that, we will be able to do all these presentational things with custom properties instead of attributes. But right now, this is not supported pretty much anywhere. It's implemented in Chrome, but behind a flag. So what can we do right now? We can't get quite to that level of beautiful API, but we can get sort of close. This is the kind of API I will teach you how to create. So let's suppose you want to have a button that has a glossy attribute, where if you set it to the value on, it creates this kind of styling. Whereas if you set it to the value off, it's flat. And here, I've applied it to every even button to show you the difference. Or I can apply it to every odd button. Or I can apply it to every button. And notice that there's a number of things that this is varying. When I set it to on, can you try to spot how many things are changing here? The line height is changing. The background is changing. It's pulling in a gradient. The border is changing. There's a box shadow that is used to draw this sort of glow at the top. So how can one declaration control all these things, given that we don't have conditionals right now? So the root of this is called space toggle. And it's kind of a hack. But hacks can be OK if they're not visible to the people using your component, if they are internal. Those are the kinds of good hacks, the ones that people, including your CSS, people including your design system or using your component, don't need to know about. So the root of this space toggle hack is that white space is a perfectly valid custom property value. So take a look at this code. We've set glossy to white space, so when the browser substitutes this var function, what is the final background value we get? It's this. Just white space and then a color. So we get a flat color. But if glossy is not defined, then we get a background, because that's the fallback of the glossy variable. And how can we pull this in at will? How can we set glossy to a not defined value at will? We can just set it to initial. And that's what initial does. It gives it the same value that it would have if we never set it in the first place. So once more, initial triggers the fallback. White space, or nothing at all even, replaces the entire var reference with nothing, and we get just the rest of the value. And by doing that, we can toggle on and off very different things. Now, one point where it's difficult to apply the space toggle is what happens if we want to have essentially an else value? If we want to have, like the line height here, toggles from 1.5 to 1.1. So how do we have an else, essentially? How can we say, if glossy is on, then 1.5. If glossy is not on, then 1.1. So it's a little tricky because we have to define the else value through a delta, through the difference. But we can do it. Here, if glossy is set to white space, then you get this. You get the 1.5. If it's not set, you get the 1.1. Or if it's set to initial, same thing. Why does this work? Because once it's set to white space, if it's set to white space, this entire thing becomes this, which becomes 1.5. But if it's not set at all, then we get the fallback, the minus 0.4. And 1.5 minus 0.4 is 1.1. So to recap, because that can be a little tricky, so we are actually discussing having a proper ternary function in the CSS working group. The first thing will happen eventually. Maybe not with that syntax, maybe not with that name, but we are discussing it. It is coming, but it's going to be in the future, like years down the line. So we can't do that right now. But we can do the space toggle version, which is more awkward, but it does get us there. And lastly, the last missing piece of the puzzle, well, one of the last few missing pieces, is the border. So this is a little different than the background example, because if we have white space, then we still get something. So if glossy is not set at all, then we get this white border here. But if glossy is set, we get no border, which is different than if border wasn't set to anything. If border wasn't set to anything, we do get a border. I don't know if you can see it. Let me see. Can I do this? There. You can see we get this awful user agent default border. So setting border to nothing actually does something. Isn't that a little weird? Wouldn't you expect that setting glossy to nothing would just have the same effect as not setting border at all? So there is a new concept that CSS variables introduced. And let me walk you through it. So back before CSS variables, if we wanted to use a new fancy CSS value that might not be supported by every browser we need to support, this is the kind of thing that we did. Let's suppose we wanted to use CSS, like new CSS color formats, LCH colors. They're not supported everywhere. So we used to use like 2 declarations, one with the value that might not be supported everywhere, and before it, we would include this widely supported value that every browser is able to understand. So if LCH colors aren't supported, then the browser will just throw away the second background declaration and use the first one. Whereas if the browser does understand LCH colors, it will throw away the first declaration because it understands the second. And this all happens at parse time. This all happens when the browser is actually parsing the CSS code. So by the time the CSS is actually evaluated, the browser has only kept one of these 2 declarations. Now, if we start storing colors in variables, we might try to do something like this. How many of you would expect this to work the same and produce the same result? Not many. What background color would you expect this to produce in a browser that doesn't support LCH? All right, so let me walk you through it. First off, the browser sees the first background declaration. It understands it just fine. Yeah, this is a background property. I know what the background property is. It's set to a var function. I know what the var function means. Fine. Then it moves on to the second background declaration. The browser's like, sure, I understand the background property. I understand what the var function means. So it throws away the first one at parse time. The second one overrides the first one because at that point it doesn't know what the var function will resolve to. Because keep in mind that this can change at any point during the execution of during the lifetime of the page. So the browser might, when the browser sees a var function anywhere in a declaration, it must optimistically keep everything because even if this is not valid right now, it might become valid in the future. So at computed value time, where everything is substituted, that's the time when the browser realizes that, hey, I can't actually use this. So what does it do? It declares that this is invalid at computed value time, which is a concept we needed to invent to make CSS variables possible. And how does it treat invalid at computed value time declarations? Because at this point, it's already thrown away the previous declaration. It cannot use that as a fallback anymore. So instead, it just treats this as unset. So anytime something is invalid at computed value time, it basically becomes the same as if it was set to the keyword unset. How many of you know what the keyword unset does? Only 2. OK. So the keyword unset makes the property inherit, if it's an inherited property, like color or font weight, or it sets it to its initial value, if it's a non-inherited property, like border or background. So it's basically as close as we can get to basically resetting the property without having any other info about it. And this invalid at computed value time concept is invoked many times in many different situations. It's invoked if the browser doesn't understand what you've set a property to, even if the value is valid for other properties. Like 42 degrees is a perfectly valid angle, but an angle is not valid in a background. So this would become invalid at computed value time. Or if even though white space is a perfectly valid value for a custom property, it's not a valid value for regular CSS properties. So if after all the substitutions you end up with something that's empty, that is also invalid at computed value time. This is why we still got something in the border case. This is why it still overrode the user agent border, because after substitution, the border value was empty, so it became unset. And for border is not an inherited property. So unset is basically equivalent to initial. And the initial value for border is no border. Now, if you also set it to a property to a value that doesn't have a value, that is not set anywhere, that is also invalid at computed value time. Or if the property is explicitly set to initial. Oh, and that can apply to any part of the property. If any custom property reference doesn't resolve to an actual value and doesn't have a fallback, that is, the entire declaration becomes invalid at computed value time. And also if you have cycles, here foo is referring to bar and bar is referring to foo, so they both become invalid at computed value time. And you can have cycles with just one property, because CSS variables are reactive. So it's not like JavaScript where you can say I equals I plus 1. JavaScript has an order of execution. You can execute one statement and then the next statement. Because CSS variables are reactive, they don't have that. Like foo would have to simultaneously be foo and foo plus 1. That cannot work. It's basically the other case where you've all experienced reactive computation is spreadsheets. It's the same as having a spreadsheet cell that refers to itself. It can't work. It's invalid. And lastly, a fallback value can also make a property invalid at computed value time. So then how can we do fallbacks when variables are involved? We just have to use the @supports rule. It's clumsy, it's longer, but it is what it is. And now the last missing piece for the space toggle hack to actually be usable in production, because like I know that right now, many of you might be like, okay, this makes sense, and it's nice that we can use this to toggle many things on and off, but if I try to submit code, if I send a pull request with code where you need to specify initial or white space to toggle things on and off, my teammates are going to want to kill me. They're going to want to chase me down the hall. My boss will fire me. So how do you actually use this in production? Well, you just alias these values to nice keywords, like on and off, or true and false, or yes and no, or something specific to your use case. All of these would be fine. But as long as they have readable names, then anyone else should be able to use them. It's almost the same as having keywords. And nobody has to know what they actually correspond to. Like, the first part would be in your design system or in your component CSS or whatever. And it's only the second part that you actually expose to other people. Another use case where the space toggle hack can be useful is for progressive enhancement. So here's an example. How many of you have heard of gradient interpolation in different color spaces that's upcoming? A few. All right. So right now, when you use CSS gradients, colors are interpolated in the sRGB color space. This produces really bad results, especially when you have big hue shifts. This is especially noticeable with interpolating from red to green. You can see there's this awful brownish area in the middle where the colors actually get darker. And we've just accepted this as this is how gradients work. But this is not how gradients have to work. If you interpolate in a different color space, you can get much better gradients. Until recently, CSS did not support this. So you were just stuck with sRGB. There is an upcoming feature where you can specify in what color space you want gradients to interpolate. Right now, it's only supported by Safari. Chrome is implementing it, but it's taking a while. So how can you use nice gradients for browsers that support them and the old shitty gradients in browsers that don't support this feature? You could use @supports, but then you would have to specify this super long thing for every single gradient, which is really clumsy. You can use a variation of the space toggle so that you could have much more succinct code. So here we've set this in LAB value on the root element, so we can use it anywhere in our CSS, because remember, CSS variables inherit. And we use a single @supports rule that sets it to the inLAB token if that syntax is actually supported. And then there is only one @supports rule in one place. And anywhere else in our CSS, we can just have a single gradient declaration. And this resolves to inlab if that syntax is supported, or to nothing if it's not supported. And there's even people that have done, like Jane Ori, who is one of the inventors of the space toggle hack. This has been independently invented by many people. She's even done like this crazy thing where she implemented an entire Minesweeper game with space toggle, and it's basically just pure CSS. Like, I don't even understand how she did it, but it's pretty mind-boggling. All right. And now for the third component, the bar chart. And this is what we're going to create. This is the API that we're going to expose. Each bar is a bunch of divs, and the percentage is specified through a CSS variable. And the theory is that like people can just use this class with appropriate bars to display different types of bar charts, and everything just adapts reactively. Like I can change this, and notice the percentage shown changes, and it's rounded. The color changes, the height of the bar changes. So how could we do that, something like this? We're going to start from something that already has the basic layout down, because this is not a talk about Flexbox. So our first attempt involves using percentages for the p variable. And then we've already set the height to the p variable, and it's directly using these percentages. And now the next step is we want to try to display this percentage on the actual bar. So we might try something like this. We might try using a before pseudo element on each bar and set the content property to our variable. But nothing happens. Why does nothing happen? Well, because if you look up the definition of the content property, it doesn't actually support percentages. So I might look at this code and think, wait a second, yeah, I can't just use a percentage directly in content. So we try something different. We try making our p variable numbers. And then, of course, we need to adjust our height code, because you can't just specify height and numbers. But that's easy. We just multiply it by 1%. And this is a point where this kind of lets me make a very important point about using CSS variables right now. You should always prefer to use plain numbers, if you can, for CSS variables that you're actually exposing to other people as part of your CSS API. Always use pure data, because you can always go from a number to anything, to a length, to an angle, to a time value, to a percentage, by just multiplying with 1 and that unit. But you cannot go the other way right now. If you have a percentage, you're stuck with a percentage. If you have a value in pixels, you're stuck with a length. That is it. In the future, we'll be able to divide and get a pure number. This is in the spec for a while now, and it has not been implemented by any browsers. So for the foreseeable future, use numbers. And also, numbers usually are usually better for whatever API you're exposing. Like you don't want your API to be too low level. You don't want people to be specifying length directly a lot of the time. You want it to be about data, not CSS values. So, however, although this allowed me to make this important point, it didn't actually fix my problem. I still don't have a percentage being shown on the bars. And why is that? Because if you look up the definition of content, it also doesn't support numbers. It supports images, and it supports strings. So how can we convert? We don't want to change our API so that p is specified in a string. Then we wouldn't be able to use it anywhere else. So how can we use this number that we've got and convert it to a string? So what we can do is we can use a counter. I'm sure you're familiar with the counter function. The counter function does return a string, and we can initialize it with a number. So if we use counter reset, we can just specify a counter right there and initialize it to the value of our variable. And notice that this worked. So even though content only accepted strings, we were able to convert numbers to strings through counter reset. Is it a hack? Sure, but it's an internal hack. Again, the API we exposed to other people was not affected by the hack. The hack is in our code. So did this work? It worked great for the 10%. It worked great here. It worked great here. 38% here. What about this? It didn't work here. This shows 0%, while this is clearly not 0. Let's look at the HTML. Aha, this is the only number which is not an integer. And it didn't work for that one. Why is that? Because if we look up the definition of counter reset, it only allows us to initialize a counter with an integer. So actually, our hack doesn't work as well as we thought. Content only accepts strings. We can convert integers to strings through counter reset. So should we give up at this point? Should we just say, well, this only works with integers, sorry. This bar chart only allows you to chart integers, sorry. Doesn't work. Or can we convert a number to an integer with CSS? Surely not. Or can we? It turns out that we can. We can use that property and define a new property as an integer and give it an initial value and everything, make it inherit. And then, instead of setting our counter to the raw value of p, we set integer to p inside calc, because this is important for getting the browser to actually convert. And then we use that integer value in our counter reset. And notice that this worked. It rounded up the percentage, but we actually wanted to round it up. So yeah, we can actually convert a number to an integer in CSS. Credits to Anna Tudor for inventing that trick. And also, we can even control how it's rounded by just adding or subtracting 0.5, which is just like plain math. In the future, we'll be able to control how things are rounded directly. And in the further future, we won't need to do any of that shit, because we can just convert directly to strings. But I don't know when this will happen. We're just discussing it in the CSS working group. It's not even in a spec yet, so years down the line. And the last missing piece of the puzzle is the color. Notice that in the bar chart I showed you, each bar has a different color depending on the value of p, which is yet another visual indicator of the size of the percentage. So we want to specify the background of each bar to a color ranging from this yellow to this turquoise based on the value of p. Like this. Basically, we want to manually interpolate. So how can we do that? We will specify each component of the color separately by using a separate variable. We'll have a hue variable that uses p, that maps p from 0 to 100, and maps it to the different hue. And also, the saturation is the same, so we can just specify it as 100%. And also, as a separate lightness variable that maps p to 50% or to 40%, anywhere in that range, depending on the value of p. So how are we going to do that? Let's specify our h value. And we should add a comment here, because it might not be immediately obvious what it's doing. We start from the start value, which is 50, then the range, multiplied by a number between 0 and 1, like the percentage of how far along we are. And then similarly, the lightness, again, we need to add a comment to make it clear what this does. But again, it's the same premise. Start value multiplied by the range, and then multiplied by a 0 to 1 value, which, since our p number goes from 0 to 100, we just divide it by 100. And then that's it. We just plug these numbers directly into HSL. And notice that this is a very valuable technique for also creating variations of colors in your CSS, like having hue and saturation and lightness as separate components. And notice that now we got the result we wanted. If you don't believe me, I can show you how this changes. We can even go beyond 100%, and it works. And this is just a special case of linear mapping. Linear mapping is any time you have a variable in one range, and you want to convert it to a variable in a different range. So there is actually a formula for this, but I don't expect you to understand or memorize this, especially by seeing it on a slide, although my slides are online, but still. So I made this little app that allows you to specify what your range is. And you can even have units, let's say 50%, 40%, whatever, and it just gives you the formula. Sometimes you may need to make some adjustments to simplify the formula, but the formula will work. And also, in the very near future, we will not need to do the math ourselves when it comes to color interpolation specifically, because we will get color mix, which allows us to just specify in what color space things interpolate in, and then we can just specify the percentage directly. And color mix is already supported in Safari. It's being implemented in Chrome, and I think there is a limited version of it in Firefox as well. And we're also discussing, but this is earlier on, a more generic mix function for doing interpolation of any CSS value, not just colors. And also, this kind of linear mapping technique allows us to have a much nicer syntax for conditionals, a much more readable syntax for conditionals, because essentially, conditionals are a special case of linear mapping. In linear mapping, you want to map, for example, a 0 to 1 range to a range of numbers, a different range of numbers, whereas for a conditional, you want to map 0 to a number, 0 to a number, and 1 to another number, and you don't actually care what's in between. So you can use the same technique if all you have is numbers. This only works with numbers. But the advantage is that it's much nicer. So we've discussed the space toggle version of a conditional before, where you had to specify the else value through a delta. With the linear mapping version, you can just specify both values in the CSS. So it's sort of much more self-documenting. And you can also do logical operations this way. We've already seen in the previous slide how you can do a not glossy, how we can have a not glossy variable, but you can also have and or, and it's just Boolean algebra. So linear mapping allows the same variable to control multiple things, either continuously or discretely. And this is very important for having higher level variables that don't just control a single CSS value, but allow you to essentially create sort of mix-ins, like variables that pull in a number of different declarations. And lastly, the last point I want to make, I'm going to make it with this sort of contrived example. Here we have an SVG. This is the code of the SVG. And right now, we're setting the center of these circles with CSS. We can specify 25px if we wanted to look left, or 75px if we wanted to look right, or 50 if we wanted to look in the center, or anything in between. But that's kind of obscure. We want something more readable, something that makes more sense. Something, for example, that will look left with at 0, right at 1, and center with 0.5. That would make a lot more sense. So we can actually define a look variable and then just specify CX in terms of that variable using linear mapping in the same way that we've seen so far. And then we can try it, and we can see that it works. 0 looks all the way left, 1 looks all the way right, 0.5 looks in the center. And that is much easier to remember. You don't have to think, what was the number that looked left? Was it 25 pixels, or was it 30 pixels? What was it? But also, that way, it allows us to decouple how the styling of this is specified and what actually controls the styling of this. So let's write some JavaScript that monitors mouse move events, pointer move events, that monitors when the mouse is being moved, and sets some variables on the root element. Why in the root element? Because then we can use them everywhere in our CSS that needs to reference these numbers. If we specify our CSS variables generically enough, they can be usable from anywhere. So we specify these mouse X and mouse Y variables. We set them to essentially percentages of the viewport from 0 to 1. And then we can go to look and set it to these variables, to mouse X. And now we went from having a statically set SVG to having something that tracks the mouse. I'm moving my mouse, and the eyes are tracking it. And the code that actually styles this SVG did not have to know about this. These are completely decoupled. So that is my last point, that range mapping allows you to decouple input from output, which also allows you to have very generic, that is also great for when you're creating code that is consumed by other people, such as design systems or components. And now for the last bit. I know that some of you might be thinking, OK, so this is all cool, but is this all a steaming pile of hacks? Like, surely I can't really use this, right? I can't go to my teammates and use this stuff. That is very hacky. However, as I've pointed out like several times during this talk, the hacks are always on the inside. So yes, I will not say that these were not hacks. They were hacks. But hacks are not always a bad idea. It is often preferable to trade higher implementation complexity to gain lower API complexity. You can always change the implementation. It's much harder to change an API. And this applies to APIs that only your teammates use, or APIs that are used by millions in an open source project, for example. It doesn't matter how big the project is. The API consumers are always at least as many as the developers of the API, and usually a lot more. So do what you got to do to expose a nice API. Write components whose CSS properties are independent and each control one conceptual thing. Write components that can work with whatever CSS consumers throw at them. Write components whose CSS properties can be modified at any point without breakage. If you need to employ hacks to do these things, so be it. It's a worthy trade-off. Don't get me wrong, this is not a license to write crappy code. This is about the many cases where you need to make a trade-off between the two, because sometimes you can't have both. Obviously, it's great when you can have both a beautiful API and beautiful code internally, but sometimes you need to make a choice. But of course, ultimately, every case is different, and the final decision is yours. Gracias.